Now, this is factoring polynomials that are the form x squared plus bx plus c. And if that factoring algorithm, what I'm going to do is I'm going to talk my way through that factoring algorithm. If you know how to factor these, that's fine. If you don't know how to factor them, what you want to do is practice what I'm telling you. Just practice in your head doing what I'm doing, what I'm telling you to do. So this is the way you would look at a problem. You would say, on number 2, you'd say this is a polynomial that's descending order. Notice it's x squared plus 5x plus 6. The leading numerical coefficient is positive. And then you would say, is there a common factor? There's no common factor. So you see, I've gone down that algorithm. Descending order, leading term positive, no common factor. Now then, the next thing you would do in that algorithm, you say, is this a special case? And we'll talk a little bit more about special cases later. But a special case, this leading term would have to be squared, which it is. This would have to be a positive sign on the constant, and that would have to be a squared term. That's 6. And it's not squared. It meets the criteria of the leading term being squared, the constant term being positive, but it's not a squared term. So you don't even have to go any further on special cases. I'll talk to you about it a little bit later. Then you go on further down the algorithm and you say this is a trinomial, 3 terms, and you go down there and it says if it factors, then this is going to factor by trial and error as a pair of binomials. And what you do is you look at this leading numerical coefficient. It is positive and it is 1. Therefore, it has to be an x and an x here. You look at the constant term, the sign in front of it is positive. That tells you that the signs that are here and here are the same sign. So you should say, look at this, you'd say same sign. What sign? Plus sign. You put a plus sign there and there. Now you integer factor the 6. Because these two numbers are same sign, that 5 must be a sum of the integer factors of 6. The integer factors of 6 are 1 and 6, first of all. The middle term is not 7. The sum of 1 and 6 is 7. If it were 7, you would have found it. Then you say 6 has an integer set of factors, which is 2 and 3. The sum of 2 and 3 is 5. That's the one. Now, because both signs are positive, it does not make any difference where you put the 2 and 3. You got it back. So now I'm going to do 6. I'm going to do the same, talk my way through that thing just like I did this previous one. I'm going to say that thing is a polynomial with descending order. Leading term is positive, right? You see what I'm talking about? Descending order, leading term positive. It has no common factors. It's not a special case because this is a negative sign and it'd have to be positive. That just kicks it out. Now then, I go on down, I say it's a trinomial, I go down to trinomials and it says, if it's going to factor, the first thing you want to try is trial and error over the integers. And that would be a pair of binomials times each other. Because this leading numerical coefficient is a 1 plus 1. That means that my variable is put in first position. This is a negative. That means opposite signs. So it's a plus and a minus. Now because it's a plus and a minus, this too is a difference of the integer factors of 35. The integer factors of 35 start out with 1 and 35. The difference is 34, that's not 2. Don't worry. The next integer factors, 2 don't integer factor, 3 don't integer factor, 4 don't, 5 does. 5 and 7. 5 and 7 difference is 2, that's what you have to choose. Now, this is a negative 2. the 5 and 7, you have to decide where does it go? Does it plus or minus? And because this is a negative, the larger number must go in the negative position. So 14. Y squared minus y minus 6. Polynomial, descending order, leading term is positive. No common factor. It's not a special case. It's a trinomial. If it factors, it's going to factor as a pair of binomials products. Because the numerical coefficient here is a 1, that means this is y and this is y. That's a negative, so the signs are what? Opposite. Plus and minus. That means the integer factors of 6, the difference has got to be 1, right? So you go 1 and 6, the difference is not 5. No good. 2 and 3, the difference is 1, that's the 1. This is a negative, means the larger term must be negative, right? So this is factor. 22. 22, p squared plus 2p minus 35. All right. Polynomial is descending order, leading term positive. No common factor. It's not a special case. That's negative. It'd have to be positive. Trinomial. I go down to trinomials. It says if it's going to factor, it's going to factor as a pair of binomial products. The leading numerical coefficient is 1, which means that I have put just a p and a p here. This is negative, constant term negative, so the signs are opposite, plus minus. The middle term must be a difference. 1235 was what? 7 and 5. The difference is 2. Now, what goes where? Well, this is a positive, so the 7 must be positive. The larger number must be positive. Smaller number negative. And you got an integer factor. Okay, 30. If I'm going too fast, just slow me up. If I'm not going fast enough, I can go
Okay,
fast.
I got a question. How do you know, you said, like, how do you decide if the 7 was in the negative or in the positive?
See, this sign right here is positive.
Okay.
So that means the larger number must be positive when you take a difference.
Okay.
So then that would place this 7 in that positive position.
And then if it was negative?
If this were a negative sign, then that 7 would have to be over here.
Okay.
Because, you know, you see I'm talking about a difference and a sum, you know, in things. But then when I'm trying to place things, I don't know. Did that answer your question?
Yeah, that makes sense.
Okay. All right, so now, notice polynomial, descending order, leading term is positive, no common factors. It's not a special case because that's a negative. So it's a trinomial. You go down to trinomials on your algorithm sheet. It says the first thing you try. Now notice there are other things that you can try, but the first thing you try is this. You try a product of binomials. This is going to be x, this is going to be x. Now you look for the sign that you're going to put here and here. That depends upon this. If that's negative, what's the sign's got to be? Opposite, right? It's the only way when you do the last term in FOIL that you can get a negative out here in the constant. So it's opposite signs. Now then, that means, because these are opposite signs here, that means that 9 is a difference. You see why I'm talking? Then you do integer factors of 70 and look at differences. 1 and 70 don't work. 2 and 35, that don't work. The difference is 33. Then you go 3, don't factor, integer factor. 4, don't. 5 does 5 and 15, or 5 and what? 160. Did I do that right? 1, 7. I think it's 5 and 14. Is that right? 5 and 14 is 7. Now the difference of those, theirs is, right? Difference between 5 and 14 is 9. Now, the 9 is positive, so where does the 14 go? It's the larger number. You want to have a positive answer, it's got to be positive. 14 and 5. Am I going too fast? Processing and taking. So here's back. 38. Y squared minus 9y plus 81. Okay, so this is descending order. Leading term is numerical coefficient of positive. No common factor. But now notice this. This is what would catch my eye. This is a squared term, is it not? And the thing that's being squared is a y. Is that a squared term? 9 9s are 81, right? 9 is squared. That's a positive. That catches my eye because it's a possibility of being a special case. Now, in order for this to be a special case, that middle term right there would have to be 2 times the first factor times the second. If that number right there were 18 plus or minus, it'd be a special case. But it isn't, so it's not a special case. If it were a minus 18, I would have y minus 9 quantity squared. I'd be done. Understand what see where I'm looking? That's why I'm looking at, is it a special case? Now it isn't a special case, so I'm just going to wipe all that stuff out. Maybe I wiped too much out. So now I'm back to not a special case, it's a trinomial. If it factors as a trinomial, if it factors, it's going to factor into a couple of binomials, because this leading numerical coefficient is a +1. That means that I have a y and a y. This constant term is positive, so it's same sign. Which sign? Negative sign. Always depends on the middle term, on what sign it is. Same sign. Now the same sign means that the integer factors of 81 sum to 9. So you're looking for a pair of integer factors whose product is 81, whose sum is 9. Well, 1 and 81, that middle term is not 82. 3, does that, yeah, 3 and 7, 27, huh? Integer factor, but that sum is 30, that don't work. Man, somebody really wants it. 4 don't integer factor, 5, 6, 7 does, right? 7 times what? 1, 13, but that's sums to 20, that don't work. And then it's 9 times 9. Does this thing factor? No, don't factor. Nothing works. When you get to the middle, you're done. You know, you can do your integers up till you get to the middle part, and then you're done. So that one's non-factorable. (42) says x squared plus 21x plus 38. So it's a polynomial, descending order, leading term is positive. It's not a special case because that 38 is not squared. So then I go down, it's a trinomial. I go down to trinomials, and if it's going to factor, it's going to factor as a pair of binomials. This numerical coefficient is 1, so that means that I got an x and an x. This is plus, same sign. What sign? Plus sign. Plus, plus. Now, that means that 21 has got to be a sum of the integer factors of 38. Obviously, it's not 1 and 38, right? 2 and 19?
Yes.
Yep. So a 2 and 19, and I got it, right? Z squared plus 14z minus 147. Polynomial, descending order, leading terms positive, no common factor. It's not a special case. It's a trinomial, go down. Pair of binomials. Leading numerical coefficient of the z squared is 1, so it's just a z and a z. Opposite signs. Now then, that means that 14 has got to be a difference of the integer factors of 147.
So 7.
Okay, what'd you say?
7 and 21.
7 and 21.
-7.
So this is 14 is a positive. The larger number, 21, must be positive, and the smaller numbers must be negative. Now, if you didn't get it like Damon got it quick, just do the 1 and 147. And then go 2 don't work. 3 would work, right? So you go 3 and 49. 4 won't work. 5 won't. 6 won't. And then you'd get 7 and 21, and you'd get to it. Just work your way through it. Don't worry about somebody else gets it quicker or faster or something. Okay, 58. X squared plus 10x minus 75. Polynomial is descending order, leading terms positive, no common factors, not a special case, it's a trinomial. If it factors, it's going to factor into a pair of binomials. The first terms are going to be x. The signs are going to be what? Opposite. Now, that means the 10 has got to be a difference. So what you do is you 1 and 75 don't work. 2, 3 and something. 3 and 25, that don't work. 4, 5, and what? 15. The difference there is 10, and you got it. Now that 10 is positive, so what's got to be positive? The larger number, 15's got to be positive. You got 5. Okay? You can, if you just wheel through it and just talk your way through the problem. 58, 60. B squared minus 25b plus 126. Polynomial descending order, leading terms positive, no common factor. It's a trinomial. I mean, it's not a special case, it's a trinomial. And if it factors into binomial, pair of binomials. This has got to be B and B, same sign, negative sign. 25 is the sum of the factors, integer factors here. 1 and 126 don't work. 2 and 63 don't work. 3 and 42 don't work. 4 and don't, 4 don't integer factor, 5 don't, 6 does, 6 and 21. I don't think I'm there yet, am I? 7 and 8, and, no, 8 don't integer factor. 9, have I lost something there? 4 don't. 5, 6 don't. Yeah, 6 does. 21. 7, 8 don't. 46. 9 don't. 10.
Seven does.
Does 7 factor?
Yeah,
7 and 50. 7 and 1, 18.
Yeah, 7.
There you go. That's the one. It's the one I was looking for. Lost it.
Okay, I get it.
Okay.
Can you explain why you use both negative signs on both?
Okay. When I look at this, that constant term is positive. That's the only way that I can get it positive there is when the last terms are both same sign. But I have to get a negative sign here. So this says same sign, this says negative sign.
Okay.
Because they both have to be negative to have a middle term of negative.
Okay.
The last term, when it's positive, it's same sign. When the last term is negative, it's opposite signs. And then which side, when it's same sign, depends upon the middle term. No, I'm telling you.
Okay, I'm sorry.
Which sign, when it's same sign, depends on the middle term. See, if this were positive and this were positive, then it would be both signs plus. So when you look at this, if this is a positive here, you always say same sign. What sign? This sign.
What? I'm sorry.
Okay. Whenever you look at it and the constant term is a positive, always say same sign. Both positives, both negatives. Which sign? In this case, negative. The middle term will always tell you what sign when it's same signs.
That makes sense.
If it's negative out there in the constant, then the middle term don't make any difference. It's opposite signs.
Okay. That makes sense.
That's good?
Yeah, that's a lot better.
I'm just gonna go back. That's why when you look at the constant term and it's positive, say this, same sign. And you say which sign? Middle term. That's. (74). Now notice these problems are different. They have a form ax squared plus bx plus c. That means the numerical coefficient of that leading term is going to be something other than 1. Now there's several things that can happen with that. What we're going to look at is going to be common factor. So you just go through your algorithm. You start at the top. You say, this is a polynomial that is descending order. You always want to make sure it's in descending order first. Then you look at kind of two things. You look at, is the leading term positive? If it's not, then look at common factor. Because you can make that leading term positive if it's negative by taking out a common factor of negative. But you might want to take something else out. Now notice, this is descending order, leading term is positive. And the next thing is there a common factor? Is there a common factor? There is. It's a 3. You take the common factor out. Now if you don't take that common factor out, you might be able to factor, but it's going to be harder than it would be if you take it out. Now then, the 3 is not factorable any further, but this term, this trinomial, is factorable. Now, you want to always look at that again, and you say, is that trinomial got a common factor? Does it have a common factor? No, because you might have missed another common factor. Now then you say, is that trinomial a special case? No, it's not a special case. Then it's a trinomial, and the thing to try is a pair of binomials. But here's the thing people forget. They forget to bring that 3 down, because the 3 is part of the total factorization. So I would suggest, before you broaden your little 2 brackets, that you bring that 3 down. Because if you don't, what is it? Your end result is what? Wrong. You lose points. Now then, you're trying to factor that x squared plus 5x plus 6. It's going to factor into x and x. The constant term is positive, so it's same sign. What sign? Matt? Both positives. That means that you're going to take factors of 6, integer factors of 6 that sum to 5. What are the integer factors of 6? Sum to 5. 2 and 3. So you put 2 and 3, and you got the thing factored. Right? Let's look at 80. It says xy squared plus 8xy plus 15x. Now notice that's a polynomial with descending order in y's, but not x's. But what about that x? It's a common factor, and you can take it out. So you can take the x out and get y squared plus 8y plus 15. Now then, that y squared plus 8y plus 15 is a trinomial that's not a special case. So if it factors, it's going to factor by a product of binomials. But when I bring it down and set it up, what do I want to bring down first? Bring the x down, set up my brackets for my binomial factorization, and then what am I going to put in the first position for my binomial pairs?
Y.
A y in both,
Plus for both.
and a plus for both. This plus 15 says same sign. What sign in front of the 8 is a plus? So it's plus for both. Now what two numbers whose product is 15 sums to 8? 3 and 5, right? So it's 3 and 5, and you got it factored. Okay, 82. Says a negative 2a cubed minus 6a squared minus 4a. Now notice that polynomial, it's descending order, but the leading numerical coefficient is what? Negative. You want to fix that. Now you can factor with it negative, but I'm telling you it's going to be hard. You want to get that leading numerical coefficient positive. Then you want to, in the process, because you have to factor out a negative sign to change it to positive, is there anything else that factors out of that thing? Does a 2 come out? Does an a come out?
Yes, A.
So if I go minus 2a, I get my thing straightened out. Then it's a squared, right? Plus 3a plus 4. Be sure you get your signs right. I'm going to take that negative sign out. Does that make sense? Do you see it? Okay, Aaron, do you see it? Use a wrinkle on your forehead. Yeah.
It doesn't show you.
Okay. All right, so now that thing in the bracket is a trinomial, right? It's a trinomial. It's not a special case. Even though you see, you might be tempted to say it's a special case. This is a squared term, the 4 is a squared term, right? The middle term, though, in order for it to be a special case, would have to be 2 times a times 2. It'd have to be a 4a, and it's a 3a. So it's not a special case. So now what you have to do is you have to do a trinomial and a factor by trial and error. Now, what am I going to bring down first? Negative 2a, and then I'm going to put a pair of binomials. And I'm going to put in the first position what? A,
Both sides are positive.
and both positive. That's positive and that's positive. So this one says same sign, that says plus sign. Now, two numbers times themselves is 4, whose sum is 3. Not possible. There's your factorization. Not possible. Okay. So what number was that? That was 86, right? 90. Says 3a cubed minus 9a squared minus 54a. Polynomial, descending order, leading terms positive. Is there a common factor? At least an 8. And there's a 3, right? That 3a comes out of there. That leaves the first term as a squared, the second term as a plus 3a, and the third term as a minus. When 3 comes out of there, what is it? 18? Is it 18?
Why is it a plus 3?
Because I made a mistake. Thanks, Matt. Good observation. Now, I have to look at what's inside the bracket, and it is it's a trinomial, and it's not a special case, so I'm going to do it by trial and error to see whether it'll factor. Now, we saw from the last one, it don't have to necessarily factor, but you know, that's what I'm going to use to try. So what do I bring down first? The 3a. Then I'll put brackets for a pair of binomials. What am I going to put in the first position for my binomials? An a and an a. What are my signs?
Negative, opposite.
Because this is negative, it's opposite sign, right? Now, this is saying what integers multiply to 18 whose difference is 3. Multiply to 18 whose difference is 3. 6 and 3, right? Isn't that right?
Yes.
So now, this is a negative 3, so what has to be negative?
6.
The 6 has got to be negative. The larger number must be negative, the smaller number positive. Now remember to find that 6 and 3, I went 1 and 18, difference is 17, 2 and 9, difference is 7, 3 and 6, difference is 3, and I found it. So just, if you don't see it right away, just remember to go down through it. This is my factorization. 94 says a squared minus 15ab plus 50b squared. Now notice that's different. We're descending order in A, we're ascending order in B, right? Now that trinomial, the leading term is positive with descending order in A, ascending order in B. No common factor. But now if that thing, it's a trinomial, it's not a special case, by the way. If it's going to factor, it'll have to factor into a pair of binomials. And then the leading term in my binomial pair is going to be A, and A, what's the sign going to be?
Negative.
Same sign, negative sign. Now, there's going to be some number, but it's going to have a B on the backside, right? We have to have a number there and there. And that number is going to be such that the product is 50, the sum is 15. What is that number? Well, we can go 1 and 50,
10 and 5.
that's 51. 2 and 25, that's 27. 3, 4, 5, but you'll ultimately get to 5 and 10. 5 and 10, you put the 5 and you put the 10. And now it's the factor. $98. Says y squared plus 85 yz plus 36z squared. Okay, now that thing is descending, it's a polynomial descending order in y, ascending order in z, no common factor. It's not a special case, although this is a squared term and this is a squared term. This squared term is y, and this squared term is 6z. But when you take 2 times y times 6z, you don't get 85 yz. So it's not a special case. So then it's a trinomial, and if it factors, it's going to factor in the pair of binomials. And my leading term in my binomial is going to be y. This is plus, same sign, what sign? Plus sign. My trailing term is z. Now then, product is 36, sum is 85. Is that possible? The best you can do is 1 and 36 and get 37. Anything, if you go 2 and 18 is 20, it just goes down from there, right? This is non-factorable. So there's what it is, 98. 102. B to the fourth minus 3b cubed minus 10b squared. Polynomial descending order, leading numerical coefficient is plus. Is there a common factor?
X.
What is it?
Squared. How many p?
B squared.
B squared.
You sound like me, x squared. B squared. B squared minus 3b minus 10. Now we looked at that trinomial inside there. It's not a special case. So what are we going to bring down first if we try to factor? B squared. Room for a couple of binomials. Put a B and a B. What sign is it?
Opposite, negative,
Yeah,
positive.
opposite, plus and minus, don't make a difference where I put them. Now, two numbers, times itself is 10, whose difference is 3.
5 to 2.
So, what, does it make a difference where I put the 5?
Negative 5.
It's a negative 5, because it's the only way I can get a negative 3. So there's my factorization of that problem. $106. Says a negative x to the fourth plus 11x cubed plus 12x squared. Okay, it's a polynomial, descending order. Leading numerical coefficient is what? Negative. I want to get that out, so I'm going to be taking a minus sign out of there. Now, is there any other common factor to pull out? Any other common factor?
Negative x squared.
There's an x squared, so it's a negative x squared comes out. Now then, that first term becomes a positive x squared. The second term becomes 11 minus 11x. And the third term is a minus 12. I think I got my signs right. I got 6, I wrote them right. And then every sign has to change. Okay. Now then, the minus x squared, no more factoring. The trinomial is not a special case. So if it factors, it's going to be a pair of binomials. What am I going to bring down first? Negative x squared.
Sign or opposite.
So it's x and x. The signs are opposite signs. So that means that that middle term is a difference of the factors of 12. And what are the factors? 12 and 1. Difference is 11. So which one is positive?
1 is positive.
1 is positive and the 12 is negative because you have minus 11. And so this is the factor form. Okay. 110 minus 3x cubed plus 36x squared minus 81x. Descending order, leading terms negative. Is there? I'm going to take a negative out. What else do I take out? 3. Anything else?
X.
And x. So then that makes it x squared minus 12x plus, let's see, that's going to be 27. Is that right? Now then, that trinomial inside there, I'm going to try it over integers, factoring it as binomial. It's x and x. The signs are what? Both negative. Now, factors of 27 who sum to 12. Okay, 9 and 3 don't make any difference where I put it. And there's my factorization. Okay, so this is